Okay then, welcome to this presentation using Trompeloeil, a mocking framework for modern C++. My name is Bjorn Fahller. Those of you who saw the lightning talks yesterday know that I learned programming in the early 80s. Wrote my first C++ program, I think 93, maybe 92. I'm not entirely sure. Currently, I'm working for NetInsight, where I write software for networking equipment, running embedded Linux. I'm writing them in increasingly modern C++, mainly C++ 14 these days. Trompeloeil here is not my job, though. It's a hobby project of mine, has been for 2.5 years, roughly, a bit more. Before I get too far into this, I should ask, what experience do you have of mocking? Someone here who has, has no experience of mocking at all, you went here to try to get an idea what this mocking thing is. No, in general, not C++ specifically, but in general. Okay, but there were a few hands. Anyone who's frequently using mocking? All right, good. Which mocking frameworks do you use? Gmock, okay. Any others?
Bacon.
What did you say?
Bacon.
Bacon? Fake it. Fake it, yeah, okay. I heard about that just the other day. That was a new one for me. Those of you who use Gmock, you will think things that I present, the easy stuff, will feel quite familiar. And the more advanced stuff will not feel very advanced compared to when you use Gmock. Right, the name, Trompeloeil. Style of representation in which a painted object is intended to deceive the viewer into believing it is the object itself. Amazingly apt for a mocking framework. Since when you do unit testing and you want to test a unit, a single class or a small cluster of classes together, you want to test them in isolation without the rest of the system. So you fake it, you fake everything else, and deceive the object into thinking it's interacting with the real world, but it's just fake all of it. The literal translation of Trompeloeil is trick the eye or deceive the eye. If you go to the Wikipedia page on Trompeloeil Arts, you see some examples of these. The murals are very popular. Some are really subtle. I don't know if you can see the fly on the frame below the portrait to the right. I really like that one. I'm going to blaze through these slides at quite an alarming pace. I do encourage you to interrupt me with questions, but if you have failed to get my attention in time, it might help if you can remember the slide number, so I can go back to it. One thing about mocking in C++, there are two main schools. There are some other alternatives, but there are two main schools of mocking in C++. You have one that uses runtime manipulation of the objects. A popular technique is to create your own vtable and just reroute the vtable pointer from the object. Completely undefined behavior, but it can be quite convenient. If the author of the mocking framework knows what they're doing, which hopefully they do. The other popular school is to work completely within the language, which means that as the language stands right now, you have to fake introspection, often using the preprocessor, or actually the preprocessor is the only choice you have. And Trompeloeil is of the later kind. To the best of my knowledge, it's completely within the language. It's pure C++14. There are no dependencies to anything other than, well, the standard library. The implementation is a single header file. It's a little bit more than 3,500 lines of absolutely horrendous macros and template black magic. It's on the Boost license, so it's, from a license legal perspective, quite available. Available from Conan. If you like that, you can talk to the Conan guys who are sponsors of this event. And it's adaptable to any unit testing framework. At least I haven't been shown one that you cannot adapt to. This adaptation thing is actually quite important. If you go to the GitHub page for Trompeloeil and just scroll down below the source code, you will find this bit of documentation and integration with unit test framework. So if you click on that one, you will see that by default, if you don't use an adapter, it reports errors by throwing an exception and explaining the problem in the what string. This is a little bit problematic. It's popular with unit testing frameworks to do so, but it is a bit problematic because typically the mocking framework will report an error when it has been called by your unit under test. So this exception reporting the error will flow through your unit being tested. So it can just swallow it and you don't see anything of it. And there are also scary situations when Trompeloeil needs to report errors in a destructor. And throwing from a destructor is not always a very good idea. Below here is a list of unit test frameworks that there are documented adapters for. So you just click on the one you like, and you will see a code snippet of 10, 15 lines. You just copy-paste it into your test program, and you're done. And if your favorite unit testing framework isn't listed, it's not difficult to write an adapter. And if you do, please update the documentation and submit a pull request so that others can take advantage of that. I'm going to introduce how you use Trompeloeil by example, and I'm falling back to a blog post by Bjorn Fahller that he wrote in 2004, this blog post titled "Mocks Aren't Stubs." The reason for that blog post was to set the terminology straight. What do we mean with a fake? What do we mean with a mock? And what do we mean with a stub? And in this blog post, he used a whiskey store as his example. And I'm just going to steal that, because whiskey. So what's going to happen now is that we are going to implement an order class. And this order class uses a store that it will communicate with. And in order to be able to write tests for the order class without having an actual store, we will write mocks for the store. And in Trompeloeil, to write mocks, what you do, to begin with, you write a C++ file that includes trompeloeil.hpp. When you've done that, you have really done the most difficult part at all of using Trompeloeil, because you have spelled it correctly, it includes a file, everything works. And the way you use it then is, you can only mock member functions in Trompeloeil, nothing else, for better or for worse. So you define your type, in this case, a struct myMock, and you have this macro make mock1 with a function and a signature. And the way this works is that this will create a mock function that has the name func as a member function in the struct. And this function will have that signature, and this one is because this signature has one parameter. So this will implement that function. It will also implement a list of active expectations. I will come back to expectations in a while. And it will implement a hook for creating expectations. An obvious disadvantage with this construction, that is, by the way, shared with Google Mock for those of you who use it, is of course this. And we all know what happens with terrible template libraries when you make this kind of thing. I think Andrei Alexandrescu explained the situation that the compiler gives you a novel written in encrypted Klingon. So you get this. Static assertion failed. Function signature does not have 2 parameters. And that is the full error message from G++ 5.4. Trompeloeil is heavily optimized, but not in the usual way. It's optimized for short and informative compilation errors, because we make mistakes. I do, at least. And I don't like wading through very long error messages trying to figure out what the problem is. I like having a short message saying, this is wrong, fix it. And it's also optimized for short compilation time. Runtime performance I really couldn't care less about, but short compilation time, because typically a unit test program, you build it once, you run it once, you build it once, you run it once. And the build time is 2-3 orders of magnitude longer, so it's the build time that is important. Going back to this, very frequently seen idiom is that you make a mock by inheriting from an interface. That is, you have a pure abstract class with some function that you want to use. So your unit under test works with the interface, and in the real world it gets an instance that does whatever it does, talk to over networks or to databases or whatever. And in the test, you have mocks instead. When you do this, please add the override. It makes life so much easier when you make mistakes. So back to Martin Fowler's example. That example was written in Java, but the idea is this. We have a store that has an inventory function. So we can ask, how many of this whiskey do you have? I have 5. And then we have a remove function from the store. So I can remove as many of what happened of this whiskey that I like. So let's see how this works. And the idea is that you have an order class where you can add things to the order, and you have a fill function where you fill the order. And the idea of the usage is just this. You create an order object, you add something to it, you get a store from somewhere, and you fill the order with the store. So we need to mock these functions. I didn't mention make const mock, but that is for creating a const member function, mocking a const member function. And of course the override, since this is a virtual function that we're implementing. And likewise for remove, now it's make mock 2 because it has 2 parameters. So we can write a test. In these examples, I'm using the catch testing framework written by Phil Nash, who is not in here right now. He is at the conference. The way you write tests is you just write test case and a name. My usage of catch in here is deliberately quite naive because it's not catch I want to show off. So I have a test case. Oh, sorry. Create an order, add something to it, create a mock store, nothing happens, we haven't done anything. Now we set up an expectation. We require that store.inventory is called with whiskey, in this case Talisker. We can do this because inventory is a mocked function. And we can do this because it is possible to call store.inventory with whiskey, and it is possible to do an equality comparison between a char star and a string. This creates an anonymous expectation object. And the parameter, in this case, whiskey, is copied into this expectation object. So if you, after this, redirect this pointer to point to something else, it does not change the expectation. If you want it by reference, use stdref. That works. This expectation object adds itself first to this list of pending expectations in the mock for this particular function. And the expectation must be fulfilled before the expectation object is destroyed, which is at the end of the scope. And here is why Trompeloeil sometimes has to report errors during from a destructor, because it's when this object is destroyed that it says, no, I haven't been called. Error. So let's be lazy and write the smallest possible order class that compiles, does absolutely nothing at all, and try to compile it, but doesn't compile. Return missing for non-void function. Many mocking frameworks assumes a default. So in this case, this returns size t, so they would return a default constructed size t. Trompeloeil is not like that. It's very easy to remember the defaults from Trompeloeil because everything is forbidden. That is the default. So you have to say, what do I want to return? In my experience, this reduces the number of WTFs over time. It may increase them temporarily when writing the code, but on the long tail, as the program lives and evolves, it saves them because you have no hidden defaults. You know in the code what happens. It's visible. So yeah, and this is the full error message. It's nothing more. So like I said, short, informative compilation errors. So I added return 50. This can be any expression. You could call rand, a very bad idea, but you could. As long as it's the type of the expression is something that is convertible to the return type of the function. So that compiles and it runs and it fails because we did a stupid implementation that doesn't do anything. So let's change that. Let's make add remember the article and fill call inventory. Okay, super lazy, nothing that works. But this compiles and it passes the test. Okay, excellent, one more test. Filling removes from store if in stock. So again, we set up an expectation that inventory is called. And we set up a new expectation that remove is called. Now you may note that these are two different lists. There's one expectation list for inventory, there's one expectation list for remove. So from Trompeloeil's perspective, these two are logically parallel. They can happen in any order, as long as both happen. So we have here two equally acceptable sequences. I agree that the chances of an implementation calling remove first and inventory then is pretty low. But if you want to do something about that, you can create a sequence object. The way sequence object works is that things must happen in the order that the sequence object have been introduced to them. So this sequence object sees the call to inventory first and the call to remove second. And now there is only one sequence of events that is allowed. I want to raise a little finger of warning about sequence. It's very much overused in my experience. You don't want to fall into the trap of over-constraining your tests. It's so easy to do that, to write tests that are so precise that the only thing that works is your exact current implementation, when there are in fact several alternative outcomes that are equally okay. So be careful. In this case, it's perfectly right to do, but remember this warning. So we can run this and it fails because we haven't called remove. So let's fix the program. So now add remembers also the quantity and fill calls remove if the quantity in inventory was sufficient, and this works fine. And there is my cue to take a drink. Not the Talisker, unfortunately. Questions? Everything I say from here on builds on what I just told you so far, so now is a very good time to ask. By the way, if you search Instagram for hashtag Trompeloeil, you find some interesting pictures. Okay, so you're too shy to ask and you didn't understand anything. So let's go on. I have some issues with this interface that Bjorn Fahller suggested. It works fine for a simple example to explain what you mean with mocks and fakes and stubs, but it really isn't a way to implement an order and a store. What if there are several order objects simultaneously accessing the store? You can get one that calls inventory, everything is fine. The other calls inventory, everything is fine. The first one calls remove, everything is fine. The second calls remove with too much. So that is no good. And maybe we want to generalize a bit. So we're not necessarily having a string as our article type. And maybe we don't really want an object-oriented design like this. So I propose a templated solution instead, where we can have an arbitrary article type. We can reserve things. So I say, I want to reserve 50 bottles of Talisker, and I get back, you got 30. And if I'm really disappointed with 30, I can cancel my reservation, or if I'm happy with 30, I can remove them. And just for convenience, during the tests, why not use a whiskey store that uses a string, because then we have a consistency with the earlier example. And just to make things a little bit more interesting, we introduce a record type too. It saves on slide space. That is important. And the use is a little different from before. We have a store. We create an order class that creates an order object that refers to the store. We add something to it, and if what we got when we added, we're happy, so we can fill the order as an example of use. So let's write a test. New test, because the game has changed. Add returns a reserved amount. So create an order object, code smell, I intentionally leak memory. You don't have to say that, Peter. There are reasons for that. We'll come back to it. I set up a requirement to reserve a record with 51 Taliskers, but this won't work because there is no equality comparison operator for the record. Could easily add one, but let's not. Let's do this instead. In namespace Trompeloeil, there is an underscore. The underscore is a wildcard that matches any value, any type. Users of Google Mock feel familiar. So we say, I require that store is called, store.reserve is called with anything. And then I constrain it. I admit my head wasn't properly screwed on that day. That this should have been when. But, okay, my mistake, you suffer. In with, we write a Boolean expression that constrains the call. So I say that the call to reserve is accepted if and only if the article is Talisker and the quantity is 51. And then I add afterwards a check that the returned value was indeed 50, even though we asked for 51. This require here is a catch thing that is not Trompeloeil. It's an assert that the variable q is indeed 50. You may notice that this _1, that is because in with here, in order to be able to access the parameters of the call, you use positional naming. So _1 is the first parameter, _2 is the second, etc. In this case, there is only one, so _2 is a compilation error instead. So a new order class, a class template that remembers the store from the constructor and where add calls reserve and returns a value. And this works. Now I cheated and didn't show you the fail because you have already seen the fail. So nothing new there. Write a new test. Fill removes the reserved items. And it's exactly the same expectation, call to reserve. Return 50, no difference. And then I add a second step where I fill the order, and with fill, there is a requirement that remove is called again with Talisker and 50. This is a very typical anatomy of tests written using Trompeloeil, that if your test involves several steps, you have one scope per step, where you, in the beginning of the scope, you add the expectations for that step, and you end it with a trigger event, a call to your unit under test. So in this case, the trigger is a call to fill, and I really expect that it is 50 Taliskers that are removed, and not 51, because it's 50 that was returned from the previous step. Again, I'm cheating and not showing the fail case, but we add some more code to the order class where we remember what was reserved. And the fill function just traverses the elements and calls remove on them. And this, of course, passes. Yeah?
Is there a reason for no cleanup? Because we run it with value.
Yeah, there is a reason, because I'm doing cleanup really, really, really soon.
Okay.
I admit that is a bad reason, but I don't advocate writing code that way. So here we do use test the destruction. So in this case, I'm taking a unique pointer. And it's really the same. In this case, I'm just doing a reset. The actual reason for having done that, since you asked so nicely, why did I intentionally leak memory, is that I didn't want to be bothered with what should happen from the destructor. And also, I didn't have to bother with the lifetime of objects, because if I didn't do here a reset, then I have a difficulty with the lifetime, because the requirement here on the call to cancel, that will go out of scope before the store object goes out of scope. So that code becomes a bit difficult to express nicely. But sure, I could have done the other tests by using a unique pointer also. So just add the calls to cancel from the destructor, and everything is good. And another test. Multiple adds to the same article are combined, more steps, and this is nuts. There's so much repetition going on. So much repetition. This is insane. Don't do that. We could instead say allow call. I'm not sure that that is a good idea, but an allow call says that this is allowed to happen any number of times, 0 and infinity, and anything in between. Well, actually not infinity. It's limited to unsigned long, long max, but I think we can approximate that to infinity. Perhaps better is to express clearly exactly how many times we want this to be called, because we want it. We know it. We are calling add twice, so reserve should be called exactly twice. And just for the sake of being complete, you can say must happen at least twice or at most, and even give an interval. I've actually never seen a use for that, but I'm sure if I removed it, someone would complain. And then we do a fill and expect that it's 50, because that is the obvious sum of 20 and 30. And what? All right. When Trompeloeil doesn't know what to do, doesn't know how to print an object, it gives you a hex dump of the memory area that the object takes up. In this case, that actually conveys some useful information. The string class obviously uses a short string optimization, so everybody can read Talisker there in yellow, right? The way Trompeloeil knows how to print is, if there is a print function in namespace Trompeloeil, it will be used. If none exists, it will look for a no-stream insertion operator and use that if it exists. It can be handy to if you have, say, a class where you have some, say you have some cached value in it or something, then the O-stream insertion operator may probably not want to show the cache, but in these error messages, it might be handy. So even though you do have a no-stream insertion operator, it might be good to write a print function that prints the information that is interesting from a test perspective. So let's write a print function so that we can print record, and it's really no more difficult than that. You have just an open namespace Trompeloeil, add a function print that takes a no-stream and your data type and format it as you please, and then you're done. So recompiling and rerunning, and we see that it still fails, of course, because we hadn't tried to fix a problem, but we see that no expectation for call or remove with 30 Taliskers. Oh. You see the bug? That was embarrassing. Let's fix it. And rerun it, and everything is OK. Good. So, questions? How recent compiler does it need to have to run Trompeloeil? G++ 4.9 or later. Clang, I think 3.5. I'm not entirely sure. 3.6, I know. MSVC from Visual Studio 2015 works. 2017 works, I think. I think I read yesterday that they came out with an update, and I haven't tested that one. Their update 3 on Visual Studio 2015 broke it completely. I had to make several changes.
It has to be
Pardon?
it has to be C++ 14.
Yes, it must be C++ 14. That is absolutely correct. What is needed is to be able to use, so in many cases, C++ 14 is a convenience. I can express it in C++ 11, but there are 2 things that are needed. And that is, I must be able to use auto in the parameter list of a lambda. And I must be able to use auto return type from a function. So C++ 11 is unfortunately out. Other questions?
One question actually.
Okay.
Can you set up and tear down kind of functionality if you do similar tests, but it's like what you
You're one slide too fast. Okay.
You have this width where you can input a Boolean condition.
Yeah.
Can you also kind of give it a lambda and have it evaluate with the parameters you
Yes. Anything, you can call functions from there, call lambdas, call whatever. So as long as it's, the question for if you didn't hear was, in this width constraint, do I have to have just a Boolean expression there? In this case, I had 2 comparisons and a logical AND. Can I, for example, call a lambda with the parameters? And yes, you can. You can call any function you like, including a lambda, obviously.
I have to write the lambda and call it immediately with the parameters, right?
Yeah, you gotta get you have to get a go or no go right there. You cannot defer it, because when what happens when the call comes to the function, it will traverse this list of expectations, and then it will check any with conditions. Say, is this a match? Is this a match? Is this a match? So I have to get a Boolean value there that says true or false.
And something else, basically the same question for the returns.
It's returns is exactly the same. It's no difference. No difference at all. The only difference is when it's called. The return is obviously only called after you have already had a match. So what I showed you so far is, well, it is the information you need to do a lot, but it is quite a lot of repetition of the same things over and over and over, and that becomes tiresome after a while. If it's a very small test suite with 3 or 4 tests, and okay, who cares? But in a large test suite, that doesn't make sense. It becomes too repetitive, and whenever you make a change, you have to make the change in a number of places. So that is a bad thing. So I have an idea. I want to be able to express a mocked store that I can construct it saying what the store holds, which articles does it have, how many of each. And it enforces the allowed and required behavior. So as long as the calls are made that follow the rules, nothing happens, but it will report calls that are not legal. And it's not actually required to handle all situations. You can still fall back to the techniques I already showed you for odd corner cases, but to get the bulk of the situations anyway. Obviously, this mocked store does not need to handle several orders because it's not the mock we're testing, it's the order. Don't fall into that trap. And I think it should suffice if I have an object that has two maps, one for the store's stock and one for what is reserved by the client. That should suffice. So I can write something like this. I'm not entirely happy with the name, but okay, I have something that expresses stock that you can call reserve on, and it has these two maps. But how do I implement this? Allow call is no use because it must be fulfilled here, and that is way too early. Named allow call to the rescue. Named allow call is actually exactly the same thing, except that you get a unique pointer to an expectation, and this expectation must be fulfilled by the time the object is destroyed. But since it's a unique pointer, it's up to you. You can destroy it at any time you like, you can hand it over to something else, whatever. But named allow call gives you a unique pointer. So in this case, we bind this to a member variable. So this expectation lives as long as an object of this struct lives. And then I can add a width and ensure that the quantity is, or not ensure, a constraint that this expectation is only valid in the situation that it is called with a quantity that is in stock. And here I'm actually referring to these maps. And then I can change these maps. So I have dot side effect, where I'm decrementing the stock, reducing the stock, and adding to what is reserved. These side effects are called in the order they appear. And in this case, I just returned exactly what was asked for. So with this, I can write a test like so instead. I still have my store as before, but I create this thing that holds the stock and reserve and sets up the expectation that you're allowed to call reserve on it. And then in the requirement, I check that remove is actually on exactly the same amount that was reserved. Now this LR thing is an ugly, ugly, ugly construction, and that is very intentional. LR means local prefix, and that is a visual warning to beware of lifetime issues, because that means that this name S here, that is a local variable, is accessed by reference. It's not a copy. So you better be sure that by the time this call comes to satisfy this expectation, that the variable S is valid. And that is trivially the case here, since S lives in a wider scope. The required call goes out of scope much earlier, so it's safe. But there is a visual warning to say, hey, beware, do you know what you're doing? And if it wasn't already obvious, this expression here is the body of a lambda, and by default, the non-LR prefixed version, it captures, but has a copy capture, and LR has a reference capture. If anyone wants to go into working with implementations, I would really like to discuss how to make a version where you expose the capture, where you can be specific. It's not difficult to implement, but I have absolutely no idea how to express it in a way that makes the code look nice. I have tried a few ideas and it looks terrible, so I haven't implemented it. But ideas are most welcome. But this new object here, says that reserve is allowed to be called as long as this object lives. What if Phil calls reserve? That is sort of bizarre, but what if? And I want to prevent that. How do I do that? Well, one thing is you can say, forbid the call. So you may wonder why forbid call. I said that the only default in Trompeloeil is that everything is forbidden. But this isn't the default. We already have calls allowed since in this stock with reserve object. So this forbid call again creates an expectation for reserve, adds it first in the entry. And what happens then is that if you have multiple expectations on the same object, the same function, they are tried in the reverse order of creation. And this can be quite handy. You can set up, like in this case, you can set up a default behavior early in your test. And then you can override that temporarily in certain steps in the test and say, but here, right here, the default does not apply. Here are the new rules temporarily, right here. So here we override, because this reserve is unconstrained. So it will always match any call to reserve and will result in the test failing with a message saying call to forbidden function. An alternative is, of course, to just let this stock with the reserve thing have a shorter lifespan. The disadvantage is that I don't have access to the map, but I think I like that construction better, but at least I have showed you the alternatives. I promised one kitten. So another test where we add multiple articles. So I add both Oban and Talisker. I want to make sure that both work fine. And I express that by creating this stock with reserve that has both Oban and Talisker in stock. And in this case, I check using this LR thing. LR works with side effect 2 and with return 2, by the way. So I check that the quantity is exactly the same as what's reserved, and then I erase the entry from the reserved map so that that call is not allowed again. Yes? What about the lifetime of the test order object? Yes, what about it? Ah, okay, I'm leaking memory, yes. Right, yeah, that's bad. I agree, sorry.
So maybe you leak would have helped.
Yes, or actually just creating it on the stack, yeah.
Maybe you copy-paste it from Java.
That is, copy-paste from Java, no, that is very unlikely. But I'm glad my code reviewer has woken up. I think it's better to, instead of allow it be precise, say that it is 2 calls. Like I warned you about earlier, don't over-constrain, but this is not over-constraining. We expect exactly 2 calls. More is weird, less is weird. And I really should actually have added a require that the reserve was empty, but I ran out of slide space. So, but now you've seen that. So is this an improvement for readability? I think it is. Maybe not so much for these very small things, but if you have larger tests where more things happen, yes. Questions? Yeah.
Are then the other calls still allowed?
Yes. The question was if I have an allow call with a wide expectation, allowing pretty much any parameter, if I then have a forbid call later in a local scope that is constrained to only a certain parameter or a narrow range, then it means that exactly that narrow range is forbidden. So when it traverses the list of expectations, it will come to this forbid call, and it will see that no, it does not match, and then we'll try the older one. Other questions? I don't. I do not deal with private members. What you test with mocks is you test visible behavior. Something that is private is by definition not visible behavior. It cannot be. Other questions before going on? You're making me finish early, I think. Okay, so everything is fine, we're happy, and then in comes the evil product owner with new requirements. It must be possible to optionally get notification through a callback when an article becomes available in stock. And this should be an optional extra parameter to add a std function. And the implementation of add must request notifications when the return quantity is a disappointment. Okay, so new function parameter that defaults to nothing, just sanity check that I haven't destroyed anything. Back to our mock and introduce a convenient type alias and a notify function. Make mock 2 in this case, since it takes an article types and a callback. And now comes a fairly advanced test case. Okay, so I set up a requirement that notify is called with oben and any callback. And as a side effect, I save the callback in a local variable. And then call add with a lambda that changes the value of another local variable. And the add to call is with one too many, so I know that there will be disappointment here, so the call must happen. And then call the callback and ensure that it was the right callback, that the local variable, the Boolean here, flipped to true. And it's not a great surprise that that didn't work because I haven't implemented it. Unexpected, unfulfilled expectation. Store.notify open did not happen. Okay, now that makes sense. So let's make function add a little bit more complicated and say that if the return quantity is a disappointment, then call store.notify. That shouldn't have failed, should it? And it didn't. It was another test that failed. So this fix broke another test. No big deal, but let's go on with something else before fixing it, looking at a bigger picture. This stock with reserve, it makes sense to say that for tests, generally speaking, notify or not notify is unimportant. We can use local overrides when it does matter. So we can just say that, yeah, it's allowed to be called, as long as it follows the rules. And the rules are really just that the callback, the std function, is callable. Did you know that you can compare a std function with a null pointer? I learned that only recently. I think it's cool. Another way of doing this is to use a matcher. In namespace Trompeloeil, there are 7 matchers, not equal, equal, less than, less equal, greater than, greater, equal, and regular expression. So we can just say that allow a call to notify with whatever name and something that is not equal to the null pointer. And if you have messed up your design truly so that you actually have 2 functions notify that would match this not equal to null pointer, you can disambiguate it by saying that it's not equal to the one that takes a whiskey store callback. If you have this situation, you have a serious design smell. But let's be honest, not all code smells of roses, does it? Yeah, some smells of whiskey, yes. But some of really poor quality whiskey. And code with a less pleasant odor actually needs tests too. So this is a construction that is available, and I've actually seen use for it for real. So it's a good thing to have if you happen to be in that bad position. So running this, it still fails because we haven't addressed the problem, but we get a different message saying that store.notify was called with a null pointer, and it really shouldn't have been a null pointer. Okay, good. Do you see the bug? It is on the highlighted line. Only call notify when we're disappointed and there is a valid callback. And this works. That example that I just showed you with capturing a callback as a local variable and call it and use it and such is, I don't know, I haven't actually seen any way to do that in any other unit testing framework, but I may be wrong. But it's, you can, okay, you can do it in Gmod. More questions? I like that picture. It's, as far as I understand, it's painted on the floor tiles in the shopping mall, so you have to stand at pretty much the right spot to get the illusion. Pardon me? Yeah.
I wondered what motivated you to write this. So maybe I'm good in the last few slides to see something distinctive. I can't see anything that you can't do in Gmail.
Yes, you have. You just didn't pay attention. No, actually, that is not true. I don't know for sure. When I started writing it, Gmod could not handle types like unique pointer. Types that were or move only or that you use R value references to. Maybe it has been added now. No. Yeah. Another thing is lifetime of expectations. I think I don't want to mock Google mock, but I think they got that one wrong in their design because the lifetime of expectations are tied to the mock object itself. So it's not possible to say that I want to check this expectation here and this expectation there. That is not possible to do. And you have this function, I don't remember what it's called, verify and retire expectation, something such, which you give a pointer to a mock object. That function is hilariously broken. You can give it a pointer to anything you want. And if it's not the object you want to, nothing will happen. So that one, I think, is really wrong. But otherwise, also to answer your question, why did I write this in the first place, is I have extensive experience of using Google Mock since before. I've just started to forget. But I found it difficult to use because it has such a huge API. I find I had always to look things up. How do I do this? How do I do that? How do I do this? This has a very small API that is very easy to remember. Other questions? Yes?
How many downloads do you get this
I have no idea. It's on GitHub, so I see how many clones it gets. But if one clone is shared by 500 people, or if one clone is downloaded, tried it, tossed it, I don't know. No idea. And of those who download it, how many keep doing pulls? No idea. I know that there are companies that use it, but I don't know how many. Okay, let's go on. I have this stock with the reserve that we saw earlier. I added also how to handle the situation where the call was made with more than actually was in stock, so we can take care of that. I am a little bit disturbed by this construction. It is sort of kind of repetitive. This is the kind of situation where you get off by one errors. And I think I've had my fair share of those during my career, so I want to stop that. So let's write a matcher. Trompeloeil had 7 matchers provided for you, but we can write our own. A matcher that checks that a value is one that matches the amount given in a map. So how do we write a matcher? Well, you use test-driven development. We start a new test program specifically for this matcher. I create a dummy type that has a dummy function that takes a record. And I instantiate a map with some whiskeys in. And try to get a feel for how should this one be used. But well, require call s, func available in stock. Maybe it could be better, but it's all right, I think. Here in this test program, I'm relying on the default behavior of throwing an exception, because I think it works fine here, and for the other cases where I don't want things to happen, if they accidentally do, catch is really unhappy about tests exiting via exception, so it will fail them with a message, so that makes sense. So in this case, I call this nonsense function with Lafroig that is not in stock. So it really should throw. And if it doesn't, I fail it. Fail is a catch thing to unconditionally fail the test with a message. So we can see what was wrong. And to begin with, I just unconditionally fail it anyway with the message, so that I can see what the error message looks like. I want to play around with it a bit until I'm happy with it. But with that in place, I can now think about writing a matcher. Writing a matcher is not very difficult. You write a function with the name of your matcher and the parameters it takes. And then you call quite astonishingly named Trompeloeil make matcher, parameterized with the type that you wanted to match. In this case, I wanted to match a record. Make matcher takes 2 functions, a predicate and a report function, and optionally data that we want shared between the two. I can, of course, if if you choose to use lambdas for the predicate and the report function, I can choose to capture them in the lambda capture. But if we have, say, a unique pointer given by value, that doesn't make sense, so I can have it as a stored value in the matcher object instead. So I'm using that here for another reason. Objects, data added at the end as stored values, they are perfectly forwarded into the structure. In this case, I want to refer to them, so I use stdref. It's handy to know. And then the predicate. The predicate is a function that takes the value to match and the stored values, if any. So if there were 5 stored values, there would be 5 more parameters there. Since I'm focusing on the error message here and not on the predicate, I'll just make a silly nonsense predicate that says, no, doesn't match, sorry. And I write the error message function. So when this function is called, the error message has already started to be constructed. So the failing value has already been printed. So the job of this function is to explain why was this not fulfilled? Why are we unhappy with this value? So it already says something like expected _1 in, blah, blah. And then I call Trompeloeil print on the container. This does not give a hex dump. Because I simplified things a little bit earlier when I talked about the print functions. Trompeloeil, sure, if you have a special print function, that will be used. If you have a no-stream insertion operator instead, that will be used. But if both those fail, it will see, is this arranged? Does it have a begin and end? If so, left bracket, element, comma, element, comma, element, comma, element, comma, right bracket. If it's a tuple, left bracket, element, comma, element, comma, element, comma, right bracket. If it's a pair, left element first, comma, second, right bracket. And it does so recursively. So this actually prints an entire map, element by element. So that is cool. Yeah, I just said that, didn't I? Yeah. So running this, we see now highlighted in yellow the error message. I think that's okay. So since this one is good, we update the change, update the test to ensure that this is indeed the error message by checking it as a regex. The reason I choose a regular expression is because before these things, there were file and line, and you really don't want to match those by exact string comparisons. Info is another catch thing, that it's a message that is printed if the test fails, not otherwise. So it gives a better visual feedback in case this becomes broken. And running this, it passes, so this is good. So another test, record with article and quantity in stock is accepted. And that is a short one because it really shouldn't fail, so it shouldn't throw, so everything should be like nothing. Since we have a fake predicate that always fails, we get the message, but that is expected. So let's update the predicate, say that if you find the article as a key in the map, then it's okay. And this works. And one final test to ensure that we get the limit okay, so we don't have an off by 1 to say that when we ask for 21 O1s, it should fail. So again, update the predicate to check that it's not enough that it is a key, but the quantity must be sufficient too. And now everything works, and now we can update our stock with reserve. So we see that we allow call for store reserve available in stock. That is cool. And this is even cooler. You can negate a matcher. I like that. Questions on matchers? Matchers are never needed, but they can.
So, have you got things like container matches and machine lock kind of stuff?
No. I have thought of adding container matchers, but I haven't yet. Like I said, the matchers available are the simple ones. It's equal, not equal, less than equal, greater than equal, and regular expressions. But I've been thinking about adding container matchers, but not yet. And if I had, this one would have been a bad example. Other questions? All right, we're getting towards the end here. Evil product owner comes in again after having adapted our tests a little bit to this, and now the order class must accept ownership of the store, and after fill it must destroy it to, I don't know, closer connection to a database or whatever. Some resource must be released there and then, and that resource is held by the store. Okay, so some simple, somewhat tedious changes. Use unique pointer instead of reference. I've changed some dots to arrows, but no big thing. But how do we test the destruction of? How do we test that the store is actually destroyed on fill? We should have like the Addams Family theme or something playing here, because now it becomes morbid. So we have a death watch. So a death watched object is carefully monitored that it absolutely must not under any circumstances die until we tell it to, and then it must die. And that can actually be handy sometimes. And the way you handle this is with a required destruction. So if the store is destroyed before required destruction, it's an error. If it's not destroyed before this required destruction expectation goes out of scope, it's an error. Compiling this fails. Bummer. Because there is a requirement that death-watched object must have a virtual destructor. This is a little bit annoying, actually, but it's not a big deal, because either you're mocking via a pure abstract base class, and then you really should have a virtual destructor anyway. Or in this case, it's templated. I'm working with a concrete class, and then it's just something in the mock. The real thing doesn't have to have it, if that is important. So with this change, compiling works, and running it gives the error message that the store is still alive. Okay, so now we know that the test can detect a failure. That is excellent. And we have our fill function here. We just call reset. And we run it, and we're home. Good. There is one thing, though. Strictly speaking, as I said earlier about requirements on different calls, different functions, they are unrelated. There is no order between them. And while we don't care about which order the whiskies are removed, we really do care that they are removed before the store is destroyed. And I can use sequence objects for that. So in this case, I want two sequences that are sort of unrelated until the end, where both things must happen. So unless sequence Talisker see the removal of Talisker first and required destruction of the store second, and seek Oban sees the removal of Oban first and the destruction of the object second. So now we have two sequences that are equally good, and both of them end with the destruction of the store. And that is okay, I think. That makes sense. To be perfectly honest, that is not needed, because destroying a mock object that has pending expectations on it is an error. But I think writing the test that way is relying on arcane knowledge about how it's implemented. I think it's more honest code to visualize what it is you want to happen. And there are definitely situations where you need to be very strict about this, very obvious. But I couldn't really figure out a very good example for that with a whiskey store. Sorry. Questions on this? All right. I will show you the full API. I don't really expect you to remember everything that I've told you, because it's quite a lot of bits and pieces here and there. But there is a cheat sheet. If you go to the Trompeloeil GitHub page, scroll down to the documentation, you will find a cheat sheet. It's actually cheat sheets, plural, 2. Page 1, it shows you how to make mock and make const mock with a name and a specifier, name, signature, and an optional specifier, like I showed you several times here. And it reminds you how to use require call, allow call, forbid call, that creates anonymous objects that must be fulfilled before you go out of scope, and the named counterparts that give you a unique pointer. And I've showed you how you use in sequence to impose orders of expectations that are otherwise unrelated, and dot times to say this must happen exactly this number of times, or no more than this number of times, or whatever. You've seen how to constrain otherwise open expectations with using with and a condition. How to manipulate data with side effect and return values. And I haven't shown you throw, but I bet you can figure that one out. And you've seen that we refer to parameters by their position using _1, _2, etc. And the LR prefix to manipulate local objects by reference. And with this, you can do everything. You don't need anything more. Page 2 is a convenience page with things that make life a little bit easier. So it's the matchers. Yeah, you may need to look up the ... for regular expression, but it's not a big thing. I briefly mentioned disambiguating matchers if you have a foul-smelling code where the matchers would be ambiguous otherwise, and that you can use operator not to negate a matcher. I haven't showed you that you can also use operator star in case a parameter is a pointer, that you can say that this matcher applies to the dereferenced value of that pointer. Rarely used, but can be convenient. And I showed you the horror stories with Death Watch and required destruction. Didn't show you named required destruction, but I bet you figured that one out too. And how to use sequences also on that. So Trompeloeil has a very small API. It's these 2 pages. Print them out, pin them to the wall next to your monitor, and you have everything. Questions? I have 9 minutes left, I think. No, 7.5. Yes? How do you handle unique pointers? You really need to use the underscore wildcard. So let's say the call accepts any. I presume you meant a unique pointer as a parameter to a call. Was that correct? Yes. So you really need to set up the expectations with an underscore so it matches any unique pointer, and then you can use a width constraint to say what is allowed. You can still use a not equal null pointer, for example, because a unique pointer is comparable to null pointer, but that is pretty much it. So you need a width to say that, I don't know, in worst case, that it is actually this exact pointer value by calling .get or something such. But it's not a problem to handle unique pointers, but sometimes you have to think a little bit about how you write the code. Happy with that answer? Good. Other questions? Yes, Peter.
If you apply Trompeloeil to something, let's say for a real project,
Yeah.
how long do your average test cases get? They fit on the slides?
That is an unfair question, since most code that I have applied this to is actually not very good code. It's, but I would say no, not really, but close. They rarely get long. If you get long tests, then you have either modeled your test code wrong, or you have a faulty interface that is too chatty.
But maybe I was asking to get picky because I'm not a big fan of using mocking frameworks because they pretend to make coupling go, or let's say, they hide the coupling you get between the test subject and the underlying used thing. And if you have quite a coupling there, writing tests should be hard if you have that coupling. So that's like, you're testing for, let's say, specific sequences of calls, so you have a complex protocol between the one object and the other one, so it gets quite a close coupling. And let's say, using mocking framework, regardless which one, easily gets you to a point where you no longer recognize the coupling because it's supposedly easy to write the mock for it, or create a mock for it, without actually recognizing you're getting a big coupling there.
Yes, and that was actually one of the reasons that I try to highlight this risk of writing your tests too close to your implementation. And there is a very strong temptation to do that. And there is another thing I want to say in response to that, and that is a mocking framework is a tool. It's not the tool. You can use other techniques also, and I strongly encourage other techniques also. But sometimes mocks are really convenient and good to use, I think. Other questions? Okay. I think I'm happy then. You can find Trompeloeil there. You can find places to spam me if you want to. Then I say thank you for your attention.